So what I'm going to do here is show you the steps that I've gone through to create the steel framework, done the analysis and done the design, and also utilise the STAAD link to AutoPipe to get the information from our piping engineer. So with this next 15 minutes or so, I'm going to show a quick presentation here of how I've gone ahead and just recorded how I created the model, how we can actually utilise STAAD. The fact that we've got a set of tools here that allow you to create grids, for example, are fantastic ways of actually creating an analysis model very accurately, so we can specify exactly the dimensions we need. And if we pre-created these, maybe we've had it in another project, I can go ahead and grab from a particular model the grid files that I've already defined, and rather than recreate them by each time, I can just go and load them up. And here I've got a grid already predefined with some the grid locations that I need for the model that I'm creating here. So I've gone ahead and started just using the snapping facility available within the grid here to create the basics of my frame, and I know the dimensions of 4 feet, 4.9 feet and 12.2 feet. I know that my dimensions are such that I need to create multiple copies of this frame in this direction. So I'm picking them up. I'm going to be going 12 feet, and I want 2 of them separated but connected together. So the program's gone ahead for me, created them and connected them together. I can then go and grab my second grid because I've got another frame. And here, this is one of the another nice feature available from STAAD, is the fact that you can create multiple frames that are unconnected. And yet we will be able to solve this. I'm sure those of you that are familiar with analysis solutions know that when you create an analysis model, when we do the analysis, we actually have to create a stiffness. But how do we create a stiffness matrix when the models are unconnected? Well, our development team have been working together to develop a method for identifying separate structures. So even though they're unconnected, we can still analyze, and we'll see later on, the fact that we've got 3 models here, completely independent of one another, using separate pieces of information to generate our analysis model. So here we've created the third frame, and within a few seconds, identify the bits of the frame that we want to connect up. So we're again making multiple copies of this frame, this time going 10.5 feet, linking them together with an open base, and it goes ahead and creates my model. So I've just used my grid, and how do I add more beams in? Well, I can simply add them in by snapping to the coordinates already created for me. And you'll notice on the side the table is automatically filling in the data for the model as I'm creating it automatically. So we've gone ahead and created all of our frames, our beams, our columns, our bracing members, all in place. And now what we know is we need to introduce additional joints within the structure. So how do I modify my frame? Well, simply by adding nodes into existing beams. So I can go ahead and select my tool to introduce joints, so that where I've got specific points of interest, I can go ahead and introduce these points, going onto my beam and putting them at exact locations, exactly where I require them. I see how I want to divide up my beam, and when I click on OK, there I can see the additional joints, the little black dots, being added to my structure, and the beams have been divided up equally for me. Now I want to have copies of this, so I simply identify them, go to my standard file, edit copy, and I can go back in and paste them back using a reference point. So in other words, how do I want to fit that back into my model? Or I can give it the fact that I want it to be moved by 5 foot in the Z direction, and then I get an additional copy of my beam. But this beam, okay, I'm going to put another one back in. This time I'm going to go forward 5 feet so that I get my additional beams either side of where I had the original. But what about, how do they connect up? Well, they've identified the fact that there's a beam there, and they've automatically broken the beam for me so that it goes into and connects up into a correct model for me. So we've got our structure in place. What am I going to do now? I'm going to start putting some section properties into my structure, and I go to the database. As I said, we get a full list of databases from all around the world. I've got some standard sections, some W sections, and maybe for the bracing members, I'm going to put some additional angles in. So now I've just got to, I've identified the fact that all of these need to be assigned to my model. So I identify the beams of my structure that I want to have particular properties, and say which property I want to have them assigned to those selected beams, and hit the assign button. And there we go. We've got the properties on that W section, the W12 by 72, assigned to all of the beams on the top of that first area. And I can just use my window, use a control key the same way that I would do in any Windows application to pick up additional beams. If I then take an isometric view, we can see all the beams that have been selected, still holding the control key, saying, look, I don't want to assign properties to these members, and I can, again, assign to those selected. So I'm just going around now, placing the properties onto those particular sections. I'm just going to pick up now some columns, and with these columns I am to assign the third property to. Here I'll hit the assign, and let's now go and grab the columns for the small section on the far hand side, and that lot I want to assign my W14s, and now I've got my properties. So how about my bracing members? Well, I've got a nice tool here that allows me to go and pick all of the members that I haven't assigned properties to by identifying them with missing properties, and now I've got them all defined. And I can now pick up and put a three-dimensional view of the structure onto my model. Okay, so we've got our properties in place. Now, what about the fact that my orientation of beams? How can I orientate the beams in a different location, in different orientation? Well, we've got a tool here, a nice tool to identify either specific angles in degrees, or we've got commands where we can introduce the actual angle command. In other words, align angles so their flanges lie parallel to the global axes. And we can identify which members we want to assign, and assign the angle. Well, the program works out what that angle is as 45 degrees and assigns the beta angle of 45 degrees to an equal angle. Whereas what we want to do now is select all of the columns. So select everything that's got that's parallel to the y-axis, and we can assign a beta angle of 90 degrees so that the whole structure is identified with the beams in the correct location.